Hello and welcome back to Physical Science Online. Here are notes about compounds. As always, I'm going to try to get through this in one video. Probably not going to happen, just looking ahead at our notes. The power of the videos is that you can pause whenever you need to. If I ever go too fast, so in the videos I'll go slightly faster than I normally would during class. So let's dive in. Ionic bonds are the first type of bond that we've discussed, and ionic bonds always happen between a metal and a nonmetal. The main way you can tell an ionic bond from a covalent bond is just to see if there's a metal in it. So you have to use ptable.com. If you hover your cursor over the metals, metalloids, and nonmetals, you can see each one as they highlight. And the fastest way to tell if you have an ionic bond is to see if you have a metal involved, because covalent bonds do not have metals. In this situation, a nonmetal, which is on the right side of the periodic table, will take an electron from a metal from the left side of the periodic table. Right side's closer to the happy at 8, left side's closer to the happier at 0, moving down in energy level. And this transfer of electrons results in what's called an ion. An ion is any time that the protons does not equal electrons, so that the atom has a charge, and ultimately that charge, let's say NaNCl, sodium is our metal, chlorine is our nonmetal. Sodium is going to give an electron to chlorine because it has an extra one, and chlorine wants one. Match made in heaven. Chlorine's now negative because it gained a negative electron, and sodium's now positive since it lost a negative electron. And so that positive and negative is what forms the bond in an ionic bond. Layman's terms. Some of the stuff from these notes are not relevant to this year. Lewis dot structures or electron transfer diagrams are something we would normally cover. Take chemistry if you're interested in drawing this out, seeing why, like in this one, there would be 2 lithiums because sulfur actually needs 2 electrons and stuff like that. Not this year. Oxidation numbers, same thing. It's a fast way of remembering what the charge would be and how many of each one you're going to need. Not relevant this year. What would be relevant is could these two things combine, and would it be ionic or covalent? Calcium is a metal, chlorine is a nonmetal, so it would be ionic. And yes, it actually would happen pretty easily. Calcium has 2 electrons to give away, so it would need 2 chlorines to bond to. That's what's happening in that drawing off to the side. And that would be your electron transfer diagram, which once again we're not doing this year. But it's still kind of good to visualize, like how is this happening? Why is it happening? And that's ionic bonds. So then we can go over to, and we'll see how much time we got left. I think I can maybe make this work. Here's covalent bonds. Covalent bonds, as I mentioned before, are 2 nonmetals. 2 nonmetals are always going to, since all the nonmetals are over to the right side of the periodic table, are always going to kind of fight for those electrons amongst themselves. And neither one can win that competition. They're both too close to the Loctet rule, and they can't win, so they decide to share. They share electrons. When things share electrons in covalent bonds, the electrons move so fast, electrons actually move at nearly the speed of light, that they fool both atoms into thinking that they're happy. So it's like the electrons at both places at the same time. That's how fast it's moving. Think like the Flash in DC Comics. You can have multiple shared electrons at the same time. One shared electron is called a single. 2 is called a double. 3 is called a triple. But it always happens between 2 non-metals. Once again, those slight differences in which one's more electronegative or whatever causes this polar covalent, which is in the notes. Not on this year's test, but still thought it was kind of cool to see that there are still charges, and that does help hold the atoms together, as well as that need to be close together to share electrons. There's some information about bond strength and stuff, not on this year's test. The cool thing from this one, though, is to see that there is metallic bonds. So the type of bond, if you're thinking in the back of your head, metal and a nonmetal is ionic, nonmetal is covalent. What's a metal and a metal? Well, there is this thing called a metallic bond. Not on any year's test. We